Although fMRIPrep runs your data through a standard preprocessing pipeline, it leaves out some steps. For example, you may remember from the fMRI tutorials that smoothing was one of the preprocessing steps, usually one of the last ones. Smoothing has been omitted by design. The fMRIPrep developers don't make assumptions about how you will analyze your data in your first level analysis, and smoothing is an important determiner of how that will be done. For example, some MVPA studies don't do any smoothing at all before the first level analysis. Even for fMRI studies, the amount of smoothing is a matter of judgment, and experiments that are focused on larger cortical areas will probably want to use larger smoothing kernels. In order to make a valid comparison with the sub-08 data that we analyzed in the AFNI tutorial, we will run two final preprocessing steps: smoothing and scaling. The background to these steps can be found in the links down below. For now, we will learn how to apply them to the current dataset. In the AFNI tutorial, we used a smoothing kernel of 4 mm on the functional data, applied with the command 3D merge. First, navigate to the folder derivatives fMRIPrep sub08 func. We will run the following code to apply the smoothing kernel. This code is in the text box down below. It's simply a for loop that runs 3D merge on all of the runs. We will also have to scale the data to ensure that the mean bold signal across the run is 100, so that any deflections can be expressed in % signal change. We will also use each run's corresponding mask that was generated by fMRIPrep. Again, the code for this is in the link down below. If you open up these images in AFNI, it should look something like this. And you can see that the deflections are around 100 in the time series. Since two separate masks have been created, you may want to combine them to use as a mask for your first level analysis. Taking the union of the masks will incorporate voxels in either mask, while an intersection will only keep those voxels that are common to both masks. In this case, we will take the union of the masks, which will be slightly more generous, by using the 3D mask tool command. If you open up this mask in AFNI, you should see something like this. Once we have these files, we are ready to run a first level analysis on the data, which we turn to in the next video.